First of all, thank you for hosting me today. I'm happy to join. I'm Ori. I'm working for a company named Akeyless. We do key management and secret management and a lot of other stuff. And today I'm going to focus about solutions for keeping secrets within Kubernetes deployments. And that's in short. Before I get started, I just want to have a brief understanding about the background. Does any of you ever try to use any kind of secret management, either a built-in secret management or external one within Kubernetes?
So I've only used the built-in Kubernetes secret manager.
So,
I've used secrets as well, but the backends are stored in, we use them at deploy time, but the actual secrets are stored in like AWS Secrets Manager. I know a lot of customers and clients are using Vault as well, but other than that, I've not deployed Vault myself, but anyway.
Yeah, just to get an understanding, you mentioned a couple of known tools in the industries like HashiCorp Vault, AWS Secrets Manager, and others. I guess each solution has pros and cons. Today I'm going to focus about integration with Kubernetes, and I think Yukiya mentioned that he used the built-in service. So
sorry, excuse me. It's a long U. It's Yukiya.
Yukiya, I apologize.
Thank you.
I'll keep that in mind. And yeah, I mean, it's very common for people to use the built-in service, and it's quite easy to integrate. By the way, in my example here, I will be using Minikube just for the sake of simplicity, but it applies to any kind of Kubernetes deployment. So basically, you can get secrets and see what kind of secrets are being used. There are a couple of secrets that are part of the control plane, which are kind of created by the control plane itself. But if people are aware, the secrets are not being kept in a very secure manner, in the sense that they're being encoded, base64 encoded, and stored pretty much in that form as part of the etcd key value store. And when you want to keep your secrets safe, the least you can do is encrypt them. And then the next question would be, okay, it's fine that I encrypted them, but where would I put the key? And for that, secret management solution have the right to do that in a very advanced manner. And Akeyless has also a solution in that form. So before I get to more advanced solution, I just want to show you how to create secrets in Kubernetes. So you can create a secret in various forms, but the most basic one is just give it some name, my secret. And secret was created. If I look at it here, I would see the secret, but it has no actual data. I can edit data to it by simply writing some text. So magic. And then base64 encode it. And just to be on the safe side, I would put the -n here. So it will go to the next line. And now I can just edit my secret. And I call it my secret. And here you see the YAML file of the secret, and then you can add data. And you can put the name of the secret here, password or any kind of key that you would like to choose, and paste the base64 string. Another way is to just to apply YAML files. This is just one example, very similar, just to show you a couple of ways to do that. And I can run kubectl get secrets. I get the secrets there. And they can also be created per namespace, which is very convenient in many senses, because if you want to launch pods in specific namespaces, then you can create a secret in this namespace and so on. And how to facilitate them. So basically, there are two ways to do that today, either through mounted file system, that is pretty standard, or through environment variables. And then the application can just read it, virtually read it, and use it in their business logic. Okay, this is in a short story. I want to show you something interesting. So if I run the kubectl get pod -a grep etcd. Okay, so I have this this pod that's running under the kube system namespace, and if I try to access it, right. So apparently there is some sort of shell, not without too many commands there, but if I try to seek for minikube etcd, this is basically the file that holds the actual database, okay? And yeah, I guess we can do something about it. So I will just exit from this shell and go into the minikube SSH, which has a much more richer shell. Yes, here. It's D. And what I can do, I can just do docker cp, and I will copy the database file just from this this container to this directory. Now I have it here, and I can run some. If you recall, the name of the string was my new secret, right? So I can run some strings on that and grep maybe something like that with secret. Let's see what I can find here. It was also new secret. Okay. So as you can see, I was able to see some JSON-like structure with a couple of values here. I can see the password, I can see username, and I can try to decode them. So do something like that, base64-d, and add echo here to make it clearer. And this is the actual password. So as I mentioned at the beginning, they are not encrypted in any form. Okay, and trust me, the remaining secrets will be stored in the same manner. Okay, so what are the alternatives? So there are a couple of secret management solutions in the market. Some of them are SaaS solutions like AWS Secrets Manager, Azure Key Vault, Akeyless, and others. And some of them are self-managed. And again, there are pros and cons, and I'm not going to talk about the differences too much. But I do want to show you our web interface. This is how the secrets are being stored, and there are a variety of secrets that you can store in our platform. There can either be keys, symmetric or asymmetric, static or dynamic secrets, and other types of certificates. I will talk about PKI certificates later on, because this is another integration with Kubernetes that might be interesting. But for now, there are a couple of secrets that I stored here. One of them is demo secret, and the other one is my secret. Okay, and
I think it would be interesting. Can you talk a little bit about the dynamic secret? Is
Sure.
is Akeyless managing that secret token for you?
Yeah, dynamic secret is a concept that is part of what in the industry is called just-in-time access or short-lived credentials, on-demand credentials. There are many names to that. But the idea is instead of storing a secret, even though it's encrypted and facilitating to the user whenever it needs it, why not create the credentials on demand and then give them short-lived, meaning
Gotcha.
that they will expire after a short time. And for that, we have created an object called dynamic secret, but it's not enough just to create it because on the back end, there is what we call dynamic secret producer that is being triggered whenever the user requests a password, and then it can create a username and password or any kind of other credentials whenever it's being asked, variety of databases, connection to remote desktop, AWS producers, and others. And I think in many senses, this approach is much more secure in the sense that the password or the token or whatever you're trying to use to authenticate cannot be stolen or used elsewhere without going through the system.
So absolutely agree.
And just since you mentioned it, it's for us it's very similar to integrate dynamic secrets and that can be used by the application or the pods themselves, because it's just like calling get secret, and then you can connect to a database and you can connect to other resources in very similar manner. Just a couple of words about authentication, because I think this is something that might interest a lot of you. So there is always the chicken and an egg problem, right? So I need a secret to get access to resources, and it's fine that you store them in a secret management platform, but how do I authenticate to the secret management platform? And for that, there are a variety of authentication methods that we support. So the basic ones are probably API keys, and there are authentication methods for mostly aimed for humans like XAML and OpenID. LDAP can be used both ways, and cloud native identities like AWS IAM and Azure Active Directory. And there are others on the way, so there are many ways to authenticate. In my particular case, I would use AWS IAM because I've launched my host on an EC2 instance. And just to complete the entire set, there is also a variety of access roles, which are role-based access control, RBAC, that you can grant access based on your identity to certain objects, to certain secrets. And why is it so handy? Because you can do a separation of duty between applications, between pods, between namespaces. So each entity gets access only to the secrets that they need to see and not the entire set. And I will show a little bit how it works. So if we're talking about per namespace, this is one of the features that we also support, giving access to secrets per namespace. So I give access to only one secret with the permissions of read and list, meaning that I can get the secret value and list it, but not create new ones, nor update it or delete it. Okay, so I explicitly mentioned this particular secret. And in the other role, I used another secret called demo secret, and this is per pod. And the way that it works is that I can just indicate what pods will be able to access it or use this role. In this particular case, it would be a pod called test env. And in the previous example, it was a namespace called demo-ns. Okay, we will see it in the example. There are other advanced tabs, and maybe I'll show them later on, but this is just to give you a background about what we're about to see. Okay, so going back, so a little bit about the solution, how it works. So the way it works is that we have a Helm chart that installs a sidecar container, and it is actually a mutating webhook. And it receives the events of pods, other pods being launched, and is able to mutate them in the sense that they can, for example, inject an init container. That's what we do. And based on the specific annotation that is part of the deployment, can inject secrets in one of two ways. One of them is mounted file system, and the other one is using environment variables. So I'll show you the configuration before we get to the deployment YAMLs. So configuration is here in values. It's pretty standard and mainly using environment variables to define the configuration. So the Akeyless URL is basically a standard configuration that talks to our SaaS. The reason that it's exported is because we also support on-prem deployments, so you can modify that to your own URL. The access ID and access type is how the Kubernetes sidecar will authenticate to Akeyless. And as I mentioned, I'm using AWS IAM as an authentication method. And the access ID is taken from the authentication method tab. If I go back there, I can see the AWS IAM, and this is it. You can just copy it, the 7YU starting, this is it. AWS API Gateway URL, this is an optional feature that you can use what we call zero knowledge encryption. In just 2 sentences, if you're interested, you can read more about the technology later on. The concept allows us to encrypt data. So basically the customer can encrypt and decrypt data without anyone but the customer being able to do the reverse operation, not even us. So this means in terms of privacy that your secrets and keys have only access by the customer and not anyone else. And for that, we offer the API gateway. And this is the definition, if you recall, that I showed you about per pod and per namespace separation or segregation of secrets. And again, this is optional feature. If I didn't define it, then all the pods within the Kubernetes cluster would have access to all the secrets that this authentication method would have. This example, I will show the difference. Yes, so going back, show you the first deployment that I would like to demonstrate. The first one is using a mounted file system. And again, I'll show you a little bit how it works. So very basic one, it's a deployment. The name of it is test file. And here is the annotation that we added. One of them is the enable disable knob. And the second one in this particular case is the inject file. If you can see here, there are comma separated lists of secrets. In fact, there should be a full pass to the secret, but both of my secrets right now are stored in the root. So I can just call them with their names and that's it. And there is a single container that I launch here, and this is Alpine based. Which runs a shell command, and what it does is just print the output of the mounted files that will be presented, and the prefix can be modified, but the suffix should match the secrets that are listed here. Okay, so this is just one way to do that. Yeah, what I wanted to do is just to deploy it. Do that in that way, and just for the example, I will deploy it in a different namespace. It's called demo ns. Just move this around. All right. Okay, so let me see. Okay, and it's running, and what we're about to do is just create the log of it. Okay, so what we see here is that I was able to print the value of this file, okay, the actual secret that was fetched. And the second one, failed, and the reason for that is because of the role-based access control that allowed per namespace access only to my secret, if you recall correctly. So if you look at the namespace here, it has access only to my secret. Okay. If I add the access to the other secret, then I would be able to see it as well. In our example, by the way, the per pod, the one that I will show you in a minute, would have access to the second one, but not the first one. It's working in a similar manner, meaning using basic annotation. But in this case, instead of the inject file, we just define a list of variables that has internal annotation. Normally, you put the actual value here, but we added an annotation, the Akeyless colon prefix, and then the pass to the secret. And what happens behind the scene is that the init container receives these environment variables because it's exported and verifies that it has the right prefix, the Akeyless colon, and then translates it in runtime to the actual value. And since this is the parent process, it will inherit, this shell will inherit the updated or modified environment variable. Okay, and the printing is pretty much similar, just print in the annotation of environment variable. We'll deploy this one as well.
Can you clarify something for me while it's running?
Sure, sure.
So I heard that you were using an init container and the web admission hooks or the injection, the pod injections. Is that two different ways to deploy the same thing, or do you need both of them still?
No, we need both of them, and that's an excellent question. I'll show you both of them. So
Okay.
this one is the webhook. It's a pod running in a different namespace. I just chose to call it Akeyless, but you can use any kind of namespace. It can even run in a default one if you'd like.
So that's the one that does the actual. That's the one that does the actual. So the init container talks to that to that one, and then that's the one that goes and retrieves it from Akeyless.
Not entirely. So this one receives the event of a deployment, and in case it matches a set of rules, for example, if the deployment has the annotation that the feature is enabled and so on, then it injects an init container that runs before the other containers.
Gotcha. Okay.
And this init container embeds in it the SDK that uses to talk with Akeyless and do one of two things, either the environment variable or the file system.
Gotcha. So me as a developer, if I'm running in this cluster, all I have to do is have the access and the annotations right. The webhook does the injection for the init container, and I don't have to do anything else.
Right. Because the trivial approach, if you are working on or maintaining a project and you have access to code, I would probably recommend to use directly our SDK, or any SDK for that matter. But in many cases, as we know, there are already existing deployments that have one way of injecting secrets, probably using Kubernetes default one, and they do not want to modify their code. They do not want to maintain it. They want it to be done seamlessly as much as possible, and this is the way to do that. Okay, that so I'll just do the same print as before, just with the environment variable. Slightly different because this is working with a different model. And this one, you can see that I got the secret value for demo secret, but I failed to get the secret for my secret. Yeah, that's in short. I just wanted to visit the audit log because this is kind of interesting. In many cases, you would like to keep track on who accessed what and when. And that's very important in terms of secrets, because then you can look for anomaly or kind of activity that was expected or not expected. And here you can see two kinds of authentication method. The latest one was Kubernetes pod auth. And this is per pod. This is the deployment that we did for the environment variable. And we can see here that this request to get this secret failed with the access denied error. And the second one was successful. And if I scroll down a bit, then I could see that the other deployment, the previous one that I done in different namespace, this is it. The authentication method was a different one, Kubernetes NS. And the first request was successful and the second one failed, just to keep track. Of course, this audit log can be filtered by a specific action. It can be exported to any SIMSOC system, such as Splunk, ELK, syslog, part of the internally managed systems.
Does this does it do any alerting in the product, or do you guys rely on a SIM to do that?
Yeah, so at the moment, we are not trying to act as a SIM or alerting mechanism, even though we have customers that requested this capability. We are considering to embed something very basic to a certain extent, but at the moment it just forward into other systems.
So I could, if I could input my Splunk forwarder details, and it would just push those logs to Splunk.
Right.
Okay.
So this is how to do that. You have a section of log forwarding. You can enable it and choose one of the forwarders. And you can even add metadata that would help you to filter or to trigger alerts, such as the source type or source, etc. Yeah, just wanted to give you a glance of the analytics screen, which is a visual representation of the activity that you can see the number of objects, the total number of objects, the request location, geolocation, and other factors such as the transactions and the time it took. This by itself can give you some insight if there are some anomalies, let's say from a different unexpected regions or unexpected times and so on. Yeah, but as I mentioned at the beginning, I know that a lot of customers or a lot of people are using the Kubernetes secrets or other secrets store. And one of the pain points in using other solution is the labor that you need to put in order to migrate from one environment to another. And for that, one of the capabilities that we've implemented is the ability to migrate secrets from one platform to another. And that can be very convenient. In our case, if you recall at the beginning of the session, I created a couple of secrets at Kubernetes in different namespaces even. And I can just try to migrate them to my environment, my Kubernetes. And the authentication can be done in many ways, like any kind of authentication to Kubernetes. In my case here, I can just use my certificate and key. This is my cluster running on this host. And I will choose the authentication method of certificate because it's one that I'm using. And this should be base64 encoded. All right, so I can just take this string, paste it here. And the same goes for the client key. So it needs to be base64. Oh, I'll do something else for the first one. The default one is to ident it to 76 bytes. We want to avoid that. So this is the client one, right? This is the actual key. few seconds, we're done. Namespaces, if you want to just to migrate subset of the namespaces, you can put one or more comma separated namespaces. If I leave it empty, I will take from all namespaces. And this checkbox is just if you want to avoid migrating the control plane secrets. This is how the secrets will be encrypted. You can choose a key from the list. The target location is where you want to put in a virtual folder the migrated secret. So I can put any kind of the name of folder, migrated secrets. And that's it. I will save it. And what will happen is that the process started and the sync was completed. Now, if I go back to secret and keys, I can see here that I have a new folder. And this folder contains all the namespaces of my Kubernetes cluster, except for the control plane one. And here I can see all the secrets. I can see in the default one, I had created a couple of secrets. This one was created from the YAML file that I showed you. And this is the username that we saw in the password. And same goes for my secret that I manually added magic string, if you recall correctly. So it was easily migrated in one click. And the same migration can happen for AWS Secret Manager, Azure Key Vault, HashiCorp Vault, and so on.
That is not an easy feature to have implemented for any of those, I bet.
Yeah, I mean, so there is always the option of throwing it over the fence and say, you know what, we have SDK, figure it out, make it yourself. But I think that one of the things that we learned is that if it's complicated, then a lot of people will avoid doing that. And we want to make the lives of the users much easier. And this is, by the way, a continuous sync, meaning that if something changes and you click on sync again, it knows how to check the delta and just update what was modified. So it's even more advanced than that.
So it won't. So you can still test it if the if the application team is having issues with getting the new secret from Akeyless, it can still use the Kubernetes secret. That's helpful.
It can work side by side. We know that the transition doesn't happen in a single day or a single hour. It takes some time to complete the testing and the POC, and it's only fair to allow side by side for a certain amount of time. And then when you choose to do the cutoff point, you can toggle between the systems. I want to talk about authenticating to Kubernetes cluster. It's somehow related to secrets. So as I mentioned, there are a variety of ways to authenticate using token, username and password, certificates, and so on. And the problem with that is that you don't have a good understanding of who accesses what and when, with the default configuration at least. And you cannot make sure that people with the right access are trying to do some operations on the Kubernetes cluster. It can be in production or in staging environment or in testing environment. You want to keep control. And moreover, you want to manage all the different users in one place. That's only a legitimate request. And PKI is just one way of using or authenticating to Kubernetes cluster. And we've implemented a mechanism that allows you to get PKI certificates signed on demand. Meaning it's in some sense, it's similar to dynamic secret because it's on demand being signed, but it's not generating the credentials because you come with your key and then we sign it for you with a private key that is managed by Akeyless. And the Kubernetes cluster can verify that this was signed by us because it has access to the public key that matches this private key that we just signed. I hope it wasn't too complicated. But here we created an object called PKI MK, and it uses this private key, MKCA. This is the RSA key that is used to sign. And what's interesting about that is that I can combine authentication methods that are more typical for humans, like such as XAML. So we are using Okta as an identity provider. And this is the Okta login that I'm using. And I configure it on my own laptop here. And all I have to do is just to modify a bit the kubectl config or kubeconfig. And it's very similar to what AWS are doing, is basically executing a command prior to running the kubectl. And this particular command is using Akeyless CLI to sign the certificate. This is a cert issuer name that I showed you, PKIMK, and the pass of the key that I want to sign, and the name of the user, and so on, other parameters. And what I need to do is just run kubectl get pod, and you'll see that my browser will pop up in a sec and take me to my Okta account. It can be any kind of identity provider, whether it's Okta, 1Password, Microsoft, you name it. And then you are able to authenticate yourself, maybe using more advanced authentication like multi-factor authentication and so on and so forth. I get a confirmation that the authentication succeeded, and here I see my cluster. I can run any kind of operation now. This is a single sign-on. I get secrets, whatever you saw before. So full access to my cluster with advanced authentication to it. And the revocation can be very easy, meaning that I can decide when this certificate will expire. So if I go back to the definition, you will see that I gave it a TTL of 60 seconds. So it means that in 1 minute from now, I will not be able to log in, and then I would have to be asked for my authentication through my identity provider again. This can be configured by the user, of course. And another interesting thing that you can see a full audit log to see that who requested the generate PKI certificate. Okay, I can filter by that and see that from this IP address, and this is the name of the requestor. So it's identified specifically to the user that triggered this command. And it's also very convenient to see who did what. Another interesting feature that I will not elaborate at this point is also the capability to do full session recording to see exactly what commands were executed. That this can be also recorded in the audit logs and sent to SIM SOC systems.
That's pretty nifty as well.
Yeah, I mean, it's only natural that you would like to protect the deployments. And today, the certificates that are being generated are typically generated for a year or even more than that. And you don't really keep track if this person has access to it and who did what, and mistakes happen all the time. You can delete deployments, you can impact the production environment, and this is something you can protect in a better way.